Okay, this is the P1 paper from October 2020. It's question number 7. It's a mixed bag of topics, this one. It's graphs and transformations. We're going to be looking at reciprocal graph and translating that. It's going to be some quadratics work on discriminant by the time that we get down here. And it will also finish off with a quadratic inequality, which is equations and inequalities. Okay, lots of different topics, but hopefully not too complicated when we do it. Let's get started. So part A says, this is my function here. Can I sketch the graph of C? On the graph, I need to say any points of intersection with axes and also where the asymptotes are. Well, most of that should work out as we're getting started with it. So first thing is to just draw out a set of axes. Okay, so we'll do that. Y and X. And then the function was 1 over 2 minus x. So I'm going to use the idea, this is what they're expecting you to do, of you don't need to draw all this stuff out, but I know what y equals 1 over x looks like. And if I know what 1 over x looks like, then I know what minus 1 over x looks like. Let's get rid of the other one. That's minus 1 over x. But if we focus on that bit there, we can see that the asymptote comes from the fact that you can't do 1 divided by 0. So in order to get 1 divided by 0, x would have to equal to 2. So that's where the asymptote's going to be. So if I now drag this just over a little bit and drag that just over a little bit, then as long as I now have my asymptote in here, and clearly label that, obviously, this is x equals 2. Could just maybe extend that on a bit, but it doesn't really matter for that bit. Okay, that's the fx equals 1 over 2 minus x. But if we go back and just check the question, they also say about any points of intersection up here. We've only got the 1 point of intersection, which is there. So I've got to work out what that is. And that will simply be when x is equal to 0. So f 0 works out to be 1 over 2 minus 0. I'm not going to do that. 1 over 2. So that value there is a half now. And then I've got all the information I need to be able to answer part A. That's part A. Done. Part B. Part B says we've got a line with the equation y equals 4x plus k, and k is a constant. It meets the curve at 2 distinct points. As soon as I see language like 2 distinct points, I should be thinking, oh, that's the discriminant work. That's quadratics. That's solving the quadratic and having b squared minus 4ac greater than 0. Let's see how I'm going to get there from my question. I'll just explain it to you on the diagram first of all, but you don't need the diagram, and then we'll see how it works out algebraically. So if I imagine the line y equals 4x plus k, I know that y equals 4x plus k is a straight line with a gradient of 4, positive 4. So the blue line I've drawn there is a possibility for what that is. And k will be whereabouts it hits on the y-axis. So what that means is then, if I consider this line, anywhere up here, it's going to hit the curve twice. As I move it down, though, there will be a point now here where it's only just about touching, so it would hit at 1 point. And then if we come down here, for example, it's not going to hit at all for a while until we come back down here. And then at some stage down here, it's going to start hitting at 2 points. So that means there'll be k values up there somewhere, and also k values a little bit lower on where it works out. So that's the diagrammatic answer to it. But in terms of algebra, I didn't even need to do all that. That was more just an explanation, an explanation for you guys, that if I actually want to do this for part B, find out where it meets. Well, it's going to meet where this equals this. Okay, so when I try and put them equal to each other, I will get a quadratic. And when I get that quadratic, what I'm going to want for there to be two values is that the quadratic, the b squared minus 4ac bit, will have to work out to be greater than 0. Let's actually do it because it's probably easier for you to understand when I actually go ahead and do that bit. So part B, we're saying where do the two lines meet? So two graphs, maybe two lines, two graphs meet when one of them, 1 over 2 minus x, is equal to the other one, 4x plus k. Just show my display there. So now, as I say, because I've understood what's going on here, I know this should turn into a quadratic, which sort of leads me on to my first step then, is to say, let's get that up there, let's multiply out and see what we get. So 4x plus k 2 minus x. Not very nice algebra here now, but at least I'm confident with what I'm doing. I'm going to get 1 equals, multiply all this together. You just take your time and do it. I'll do it down the bottom here. So I'm going to get 4x plus k times 2 minus x gives me 8x 2k minus 4x squared minus kx. And again, because of what I said previously, I know I want to turn this into your standard looking quadratic, which is something equals 0. And then I'll be looking at b squared minus 4ac. I'm going to take everything over to that side because I don't want minus 4x squared. So if I do that, I'm going to end up with 4x squared. I've got 8 minus k on that side. So if I take it over to the other side, I'll have k minus 8, lots of x. And then I'll have plus 1 minus 2k equals 0 again. The only reason I'm putting brackets around that is because I want to identify A, B, and C here because, at risk of repeating myself, what I now want to do is to say the only time this works to give me two solutions is if, two distinct solutions, two different solutions, is if b squared minus 4ac is greater than 0. So I'm going to tell the examiner that I understand what I'm doing here. We want b squared minus 4ac to be greater than 0. What's really helpful is all the way back up here, I know what I'm trying to head towards. Okay, I'm hopefully going to get that. When we do all this, just take your time again. And because it's a proof and we are doing this, just be careful in actually multiplying this all out. So b squared minus 4ac is going to be k minus 8 squared minus 4 lots of 1 minus 2k. I want that to be greater than 0. You take your time to do this, multiplying out of that bracket if you want to. You can do it as k minus 8 times k minus 8. I do that a bit quicker. But I don't want you trying to do it quickly and then making a mistake. This is important that we get an accurate answer for this bit. Here, this is a very dangerous thing to do, okay? Because you've got this minus in here and a minus in there, and it's really easy to make a mistake. I'm going to do it a little bit quicker than maybe you do it. If you want to do that, that's minus 16, and then do minus 16 times 1 minus 2k, you can do. I'm going to do it all in one go, but hopefully I don't make too many mistakes. Actually, that's not true. I just make mistakes and then redo videos. Yeah, so looking at that then, brilliant. That's what I wanted it to look like, some sort of quadratic here. Excuse me. And yeah, at this stage, what's really nice is I can check this compared to the answer that we actually had in the original bit. So if you have made a mistake somewhere, you should be able to go back and find it. Okay, so that's part B done. And now part C. Find the range of possible values of k. That simply means solving this quadratic inequality. Now, if you're solving a quadratic inequality, please, please, please make sure you need to show some working out here. And the way that I would always do it, I always say to my students, draw a sketch as part of your answer. If I want to solve this quadratic inequality, before I know what's actually going on, I know that I've got a quadratic greater than 0 and it's a positive quadratic. So I've got this shape here, which is going to be somewhere on this axis. I don't know exactly where it's going to be. If it's there, then I'd have two negative answers for k. If it's there, then I've got one positive and one negative. And if it's there, I've got two positives. But I don't know where it is until I actually draw it out. Once I have drawn it out, say that it worked out to be that, this function is less than naught here, or it's greater than naught here. But the sketch helps me as part of my answer. Right, let's actually get on, stop wittering and do it. So if I want to do that, I'm first of all just going to solve the equation k squared plus 16k plus 48 equals naught. I'm solving the equation to find the critical values. Please write that down. It doesn't take you 2 seconds to do it and really helps the examiner to understand that what you're doing is you're finding the 2 points where it crosses the axes. Solving that, well, whatever. In this case, I would be expecting that that's going to factorize. You can use quadratic formula, but get good at factorizing. It is an important technique. So we get k plus 4 equals naught, k plus 12 equals naught. So I'll get k equals minus 4 and k equals minus 12. All right, okay, that's what we just said a minute ago. When I've got this quadratic then, I actually know it's over there somewhere then, where I've got minus 12 and minus 4. So what did I want? I wanted where the graph is going to be greater than naught. Okay, greater than naught up there. So in this case, where is this graph greater than naught? Here and here. So in answer for my inequalities, it's going to be when k is greater than minus 4 and when k is less than minus 12. Okay, so that gives us our final full answer to the whole of that question, which is quite a long question, lots of different bits to it, but hopefully that all makes sense.